Hello guys, welcome back. We're gonna go ahead and conduct a RIP lab. So let's get started. Here we have a topology of RIP lab. We have four routers, R2, R4, R5, R3, and always a specific or corresponding interface is an IP shown on these diagrams. We also have two VPC. VPC1 is simulating a PC, APC1 and APC6. They're setting on the different subnet. It's 172.16.0.100 and 5.100. There are two different subnet. So the purpose of this lab is by using the RIP protocol, we can achieve this interconnection between the VPC1 and VPC6. I also give you a failure to, and then we can see the convergence. So let's get started. So just break it into two different parts. The first one is configuration of interface. So assign a different IP on specific interface. And the second part just enable RIP routing protocol. So here is just already pulled up all of the routers console. And here's the R2 router. On R2's console, we just start out with the configuration of the interface. T, and you can see the R2. For R2, there are three different IP subnets we have to configure. So it's interface E0./1/1 and R2 give IP 172.16.1.2. Shutdown interface E0./2. 172.16.3.2 and triple 255 and 0, no shutdown. Because for some versions, I already said you have to type no shutdown because for a specific version of the iOS, some of the interface is shut down by default. So also interface give 0/0 and IP 172.16.0.2. No shutdown. Okay. So you just finish the interface configuration and the show interface BRI. A BRI for brief. You can see the your configured IP and the corresponding interface name. So all done. And then we just enable router. Oh, I just paused the video and to configure all of the other three routers interfaces. Okay, so just spend some time finishing all the configuration for all four in terms of interface configuration. You're just start to configure router RIP protocol, router RIP, and version 2. give it a version 2 because version 1 will be used by default, but version 1 is deprecated. So also give a network and question mark. So give a network number, which is a major network. Here, in this case, we use 172.16.0.0. This is a B class B, a major network, which is including all three interfaces that we wanted to enable on R2, this one, this one, this one. All three are included in this major network. So you just give it a one command. And don't forget to know auto summary. So auto summary is also a deprecated function, which auto summary is a function that happens at the edge of the major network. So many times if we don't need the auto summary configuration or function, we just disable this with no auto summary. Then we just write our configuration and save it. And just pause the video and just I'm gonna configure all of the three other routers with the same configurations. Okay. Here I already finished all of the RAID protocol configuration, so you can just head back to R2 and just show IP raw to see the final result. So you can see that from R2 point of view, this row is 5.0. 5.0 is this subnet. So you can see that it goes to two routes. One is 3.5 is via R4. One is this one is via R4. This 3.5 is via R5. So you can see there are two different routes at the same time. So just you can see the topology is symmetric from R2 perspective. So R2 just send the traffic evenly from different paths destined for this subnet, 5.0 subnet. So just pull up our PC. We have two PC, PC1 and PC6, and just try in VPC 6, 172.16.5.100. You can see the pin is accessible. And also you have to check your R3's configuration. You can see the same for 0.0 subnet. They have there are two symmetric route to get to. So you can see for when it comes to traffic or communication, you have to think of as two separate procedures. One is incoming traffic, one is outgoing traffic. So for incoming traffic, you have to check the IP table or IP row. For outgoing traffic, you also have to check it out. So just give you a example of how to configure RIP, and also next step we just simulate some of the link failure. For example, R5 I go to R5 and just the interface E dot, oh, by the way, I just pin T to do the continuous pin. And then at the same time, I just interface E dot E0 slash 0 and give it a shutdown to simulate the failure. Shutdown, right? You can see the instant result. This duration is kind of like convergence time. You have to wait for RIP. In this case, you probably you have to wait 240 seconds. It depends on the different types of failure. So you can hear convergence has been finished. So you can see that from 22, sequence 22 to 107. So 107 minus 22, about 80. So around 80 seconds, the whole, the route will be failed over to the right path. So that's it.